so you don't have to remember this formula, not required at all. Just by knowing the process, just by knowing certain relations, adiabatic relations like T2 by T1 is equal to V1 by V2 to the power gamma minus 1, or T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. So just by knowing this process, you can easily determine on the spot the value of these efficiencies. Okay, so this is the efficiency for the dual cycle. Next is the comparison of auto, diesel and dual cycle. So three types of cycle we have seen. Now let us compare these cycles under different heads. The very first is for same compression ratio Rk and same heat rejection Q2. Compression ratio is same and heat rejection same. Now let us see how we can compare these cycles. Very interesting and very important. So the very first cycle, we will draw the PV diagram. So the very first cycle, as you can see, is the Otto cycle 1, 2, 3, 4, adiabatic compression, then constant volume heat addition, adiabatic expansion, constant volume heat rejection, as painted in white. Otto cycle 1, 2, 3, 4. Now, while drawing dual cycle and diesel cycle, you must remember this thing that the compression ratio has to be same. That means line 1, 2 should be common in these three cycles. Second, heat rejection should be same. That means line 4, 1 should also be common. Okay, so how can we draw the dual cycle now? So you can see in the dual cycle in green color here. So the 1 to 2 will be same. Then 2 to 5 is constant pressure heat addition. Constant volume heat addition. 5 to 6 is constant pressure heat addition. Then 6 to 4 is expansion, and then 4 to 1 is heat rejection. So here in green you can see the dual cycle. Next is the diesel cycle. So as I told you, 1, 2 has to be same, 4, 1 has to be same. So you can see the diesel cycle in red. 2 to 7 is a constant pressure heat addition process. So you can, this is the diesel cycle. So here 1, 2, 3, 4 is Otto cycle, 1, 2, 5, 6, 4 is the dual cycle, and 1, 2, 7, 4 is the diesel cycle. Now similarly you can draw the TS diagram for this. Process 1, 2, 3, 4 is the Otto cycle in white, then 1, 2, 5, 6, 4 is the dual cycle in green, and then 1, 2, 7, 4 is the diesel cycle in red. Okay. Now how can we compare the efficiency now? So efficiency, as we know, is 1 minus Q2 by Q1. Okay. So because heat rejection is same in the three cycles, Q2 has to be same. So the only factor on which efficiency is depending is Q1. That means more is the value of Q1, obviously more will be the efficiency. Q1 की value जितनी ज़्यादा होगी, efficiency उतनी ही ज़्यादा होगी. Now how can we compare this Q1? So just look into the TS diagram. Just look into this TS diagram. And as we know, area under TS diagram gives heat transfer. And just look into the heat addition process of the three cycles. Okay, process 2, 3 is heat addition for Otto cycle, process 2, 5, 6 is the heat addition for dual cycle, and process 2, 7 is the heat addition for diesel cycle. So more is the area, more will be heat addition. So as we can see, the maximum area is covered under process 2, 3. That means the efficiency of Otto cycle will be maximum, then the efficiency of dual cycle, and then the efficiency of diesel cycle. Because Q1 for Otto cycle is maximum, then for dual, and then for diesel. So for same compression ratio and same heat rejection, very important, under this head only, for same compression ratio and same heat rejection, efficiency of Otto cycle is greater than that of dual cycle, is greater than that of the diesel cycle. This is the first comparison. Now second head, for same maximum pressure and temperature and same heat rejection. Maximum pressure has to be same, maximum temperature has to be same, and the heat rejection has to be same. So first we will draw the PV diagram. So here you can see process cycle 1, 2, 3, 4 is the Otto cycle in white. Then cycle 1, 2, 5, 6, 4 will be the dual cycle in green. Now what should be the difference between the two? So as I told you, the maximum pressure and temperature has to be same. So here you can see the pressure at point 3 is equal to pressure at point 6. This maximum pressure has to be same. That's why we have extended the compression line up to point 5 from 2 to 5. This is the reason why this is extended. And then comes the diesel cycle in red. So point 5 is further extended up to the highest pressure because maximum pressure has to be same. So up to point 7 it is extended. So this is the diesel cycle 1, 7, 3, 4 will be the diesel cycle in red. Similarly, you can draw the TS diagram. Here maximum temperature has to be same. So this 1, 2, 3, 4 in white is the Otto cycle. Then 1, 5, 6, 3, 4 will be the dual cycle in green, and then 1, 7, 3, 4 is the diesel cycle in red. Okay. Now, the heat rejection has to be same, that means Q2 has to be same. You can see that 4-1 line we have taken as common, Q2 has to be same. So, for same heat rejection, obviously efficiency is 1 minus Q2 by Q1. If Q2 is same, more is the value of Q1, more will be the value of efficiency. Okay. So, same thing as we have compared in previous case, same comparison we have to make here. The maximum value of Q1 from the figure you have to determine. So, just look into the TS diagram. The maximum value of this Q1 is for the diesel cycle under area under the line 7.3, that is the heat addition under diesel cycle. So, that is the maximum area, that means heat added in the diesel cycle is maximum, then heat added in dual cycle, and then heat added in Otto cycle. Therefore, more is the heat added, more will be the efficiency. So, the efficiency of diesel cycle is more than that of the dual cycle and then that of the Otto cycle. Okay. So, this is under maximum pressure and temperature and under same heat rejection, the efficiency of diesel cycle is maximum, then dual cycle and then the Otto cycle. Getting this? Next comparison is for same compression ratio and heat supplied. So, the compression ratio is same and heat supplied Q1 is same. So, because Q1 is same, better would be if I start with TS diagram. So, just draw the TS diagram for this. So, the cycle 1, 2, 3, 4 in white is the Otto cycle. Then we have to have the heat addition as same, heat addition should be same. That means the area which is under 2, 3 that is nothing but the heat addition under Otto cycle, that should be same for diesel and dual cycle as well. So, what can be done is in dual cycle, if I draw the dual cycle would be like 1, 2, 5, 6, 7. Now, what is happening here is in dual cycle, as we know, a part is added at constant volume and remaining part is added at constant pressure, and the slope of constant pressure is less than that of the constant volume. So, it has to be further extended up to 0.6, as you can see, it is further extended up to 0.6. Why? Because the area under 2, 3 should be same as that of the area under 2, 5, 6. Because heat addition should be same. So, the area under TS diagram should be same. So, in order that the area under TS diagram should be same, so this is extended up to 0.6, up to 5, 6. Getting this? Similarly, now if I go for diesel cycle, so in the green you can see the dual cycle. Now, similarly, if I want to draw the diesel cycle, so in diesel cycle whole of the heat addition is at constant pressure and the slope of constant pressure is even less. Okay, so it has to be extended further more so as the area should be equal. So, this process 1 to 8, 9, 1 is nothing but the diesel cycle, it is extended up to area up to 0.8. So, here you can say that area under 2, 3 will be equal to area under 2, 5, 6 will be equal to area under 2, 8. Getting this? Then only the heat addition will be same, and the compression ratio is same as I told you, that means 1, 2 is already same. Okay, so, this is how we can compare with the help of this TS diagram. Now, similarly, you can draw the PV diagram as well. 1, 2, 3, 4 is the Otto cycle in white, 1, 2, 5, 6, 4 is the dual cycle, and 1, 2, 8, 9, 1 is the diesel cycle. Okay. Now, since Q1 is same, now efficiency solely depends on Q2. Efficiency is equal to 1 minus Q2 by Q1, and more is the value of Q2, less will be the value of efficiency. And how can we compare this Q2? Again with the help of TS diagram. So, more is the area under curve during heat rejection, less will be the, more will be the Q2 and less will be the efficiency. So, you can see the maximum area is covered under 9.1. So, we have to compare the area under 9.1, area under 7.1 and area under 4.1. So, maximum area is covered for area under 9.1, which is for diesel cycle. That means Q2 for diesel is greater than that of Q2 for dual is greater than that of Q2 for Otto. That means efficiency of diesel is less than efficiency of dual is less than efficiency of Otto cycle. Okay, so, for same compression ratio and same heat supplied, maximum efficiency is of Otto cycle, then that of dual cycle and then that of diesel cycle. So, this is how you can compare. These are just few examples. If you get any such point, you can immediately compare it with the help of PV diagram or TS diagram or both, and you can have the comparison and you can take down the answers. Getting this or not?